Good afternoon. My name is Maxwell Ames. I'm an application engineer here at TPM, and welcome to another webinar. Today we're going to talk about tips and tactics for complicated weldments. Let's get started. The world of advanced motorsports uses extremely complicated and detailed weldment structures to create the frames needed for racing. This Baja truck needs to be able to withstand immense forces while traveling at over 100 miles per hour over bumps that are over a foot tall sometimes. This World Rallycross frame needs to be engineered in a way that allows the driver to take massive jumps like this and not crush the car under its own weight, but also light enough so that the car can make the fastest possible time during a racing stage. This SOLIDWORKS model of a NASCAR frame shows the extreme complexity in the design of these frames. Just by looking at the model, we can tell that it is a Weldment. But could we have made this ourselves? How did the designers of this frame create the complex sketches or complex joints where the members meet? How about this single-seater dune buggy? It is far less complicated than the NASCAR frame, but it still requires a detailed 3D sketch to create it. If these complex 3D sketches worry you at all, put your fears to rest. What I'm about to show you are 3 quick tips for creating complex 3D sketches and some workflows to create their associated weldment frames. Let's get started. So, how do we create those complicated weldment frames? First off, we need to learn how to tackle the complicated 3D sketches that make up the frames. Then, we need to learn some tricks for creating the weldment profiles themselves. Then finally, we need to know some workflows for trimming the junctions of multiple weldment profiles. Let's take a look at a clip of some tactics to create complicated 3D sketches. So what I'm going to show you in this video is how to create a 3-dimensional weldment profile by using X, Y, Z construction lines. First off, I'm going to create the first construction line in the X direction. Give it a dimension. So this is a sketch line, not a construction line, sorry. That's going to be the start of my complex arc. Now, I'm going to bring in my construction lines, first off in the Z direction, then the X direction, and then the Y direction. This point that I just created is detailing the apex of the arc. I'm going to do the same operation again in the Z, the X, and then the Y direction, and finally giving me that point. Now I'm going to assign some dimensions so I can make this real life. So currently we're in inches. So we have 20 inches for our starting out profile. Then we have 30 inches. And then we have 12.5 inches. So let's finish out the vertical, or the Y direction. I'm going to give it a dimension of 14 inches. And then the X dimension for that second point is going to be 19. And then finally, the Y component of the second point is going to be 17 inches. So now we have the apex points for our complex arc. So let's tie them all together with lines. So I'm going to go to the first point, then to the second point, and then I'm going to finish it off with another piece that is exactly like how we started, another 20-inch piece. So assign my value there. So what we have is a complex arc in each apex individually dimensioned. But now I need to add sketch fillets because in order to create this weldment, it needs to be bent. So for my tool, I know that it needs to have a 6-inch radius. So I can hit check, and there you go. I have my complex 3D sketch. Now I'm going to apply my weldment to it. So I pick my structural member. For this example, it's going to be 1-inch schedule 40. I pick my individual pieces here. So working my way around, pick the individual pieces, and there we have it. So I can hit OK. And I'm done. In this video, I'm going to show you an old trick that has been around for a while and show you that it is still an effective way to create complicated 3D sketches. I'm going to create a solid model to drive my 3D sketch and in turn drive my Weldment profile. So, in order to do so, I'm going to create one sketch to drive all 3 extrusions. So I'm going to be reusing the sketch here. So I'm going to assign some dimensions. This time we're in millimeters, just to change things up a little bit. It's going to be 75, 50, another 50, and then in the center we have the 100 millimeters square. So now I'm going to be extruding this first shape up 100 millimeters. Then I'm going to reuse the sketch. I'm going to be picking the second to be 75 millimeters. And then the last one is going to be the 50 millimeters. So now I'm going to create a sketch on the top. This time it's going to be a cut extrude. Give it some dimensions. It's going to be 50 millimeters wide, aligned to the center line, and also going to be 35 millimeters tall. So now I'm going to cut extrude that to 50 millimeters, and there you have it. So now I'm going to change it to wireframe and then filter my selection by the lines. And so I can pick all the lines, start a new 3D sketch, and then convert the entities. So now I can fix up the sketch as I need, and I can use this as the center lines for my Weldment profiles. As we just saw, one of the easiest ways to dimension complicated sketches is to simply create the scaffolding of the sketch with construction geometry. We can also quickly create 3D sketches by converting the edges of a feature to a 3D sketch. Now we're going to look at some strategies to create the Weldment profiles. In this sped up video, I create the groups of my Weldment profiles based off of their orientation. If there are multiple sketch entities that are in the same direction, I select those first so that they can all be grouped together. For this frame, the horizontal and vertical groups of the frame are also the important junctions in the frame, so it is critical I pick those first. So I'm working my way through my model here and picking out all the different groups that can be grouped together. So you notice I work from vertical members to horizontal members, and then I hit a new group. Once the horizontal and vertical groups have all been selected, I go to work on selecting the individual members that are unlike other members. These members have to be selected independently by SOLIDWORKS. It is critical that these members be selected after the groupable members so that the trimming process can be more streamlined. So I'm working my way through. Each one of these members is independent of others, so I have to pick them separately. Making my last couple selections here, I'm going to zoom in and pick this last segment in the middle. So once I have that, I hit OK, and I have my full Weldment profile. By grouping like members, we save precious rebuild time in our model, and we also save ourselves time in the trimming stage of the Weldment process. Let's see how we can tackle some of the complex joints created by the profile creation process. So we've just finished creating the profiles for our single-seat dune buggy frame. But as we inspect our work, we notice that the junctions of the Weldment profiles are messy and impossible to construct in their current state. We can use the Trim Extend tool to ensure that these junctions are actually manufacturable. The easiest way to ensure that these complex junctions are correct is to first work in a clockwise or counterclockwise motion around the centerpiece and extend the pieces to it. So if we look at the model, I'm using Trim Extend. I pick the piece to be trimmed, and then I pick the trimming boundary. So I'm working in a clockwise motion. I have one last piece I'm going to pick at the bottom here. I pick the piece to be trimmed, and then I trim it to a boundary. Then we'll need to repeat the trim process in the same direction as before, so for this instance clockwise, and select the outside pieces and then trim them together. After this, we will have a nice clean joint. So again, we're working with trim extend. We change the trim type, and then we choose the item to be trimmed, and then the trimming boundary. And then once we do that, we see we have pieces in between that are intersecting. The objective is to remove those pieces so that the profile can be actually manufactured. One last piece here. So you need to select discard on that instead of keep, and there you have it. If you want to have nice clean junctions at our Weldment profile joints, we must methodically trim the junctions to ensure proper fits. If there is an improper fit, oftentimes it can be fixed, but the design tends to lose accuracy. So let's take a look at this NASCAR frame again. We all know that the simple 3 steps I share with you won't solve all of your problems when it comes to creating this Weldment. But we do know where to start now. When I look at this complicated frame, I see 3 main components. Number 1, a complicated 3D sketch. Number 2, various different profile types and groups. And number 3, complicated junctions where the profiles meet. The next time you see a frame like this, try and think of how you would make it, and if these 3 steps are also used. That concludes the presentation in the webinar. Thank you so much for attending.